Hi everyone, in this video, I'm going to lead you through some multi-step equations. So just as a reminder, when we are simplifying, we're going to use our order of operations, or PEMDAS, parentheses first, exponents second, multiplication and division third, and addition and subtraction last. But when we're solving for x, when we're solving an equation, we're going to do the opposite. We're going to look for addition or subtraction first, then multiplication and division, then exponents, and then parentheses. So to solve, we use inverse operations, so we're going to use inverse order of operations. So for number 1 here, 8x minus 2 is equal to negative 9 plus 7x. I want to look to see if I can add or subtract away some things first. So I like to combine my numbers first, so I'm going to add 2 to both sides of my equal sign to the numbers. So I'm going to put plus 2 underneath that minus 2. Negative 2 plus 2 is 0, so that cancels out, and I'm left with just 8x on the left-hand side of my equal sign. Negative 9 plus 2 is negative 7, and I put the plus 2 underneath the negative 9 because those are like terms. Those are both integers. I can put them together. I don't want to add 2 to that 7x. That 7x just stays as is because it's not alike to 2 since there's an x. But now I can combine my x terms. If I subtract 7x from both sides of my equal sign, that cancels out the positive 7x and the negative 7x so that I only have x on one side of my equal sign. 8x minus 7x is 1x is equal to negative 7. Number 2, add or subtract anything away first. I can't really since I have parentheses, so the adding 3 and the minusing 1 to x on the left-hand side, those are all like package deals. Those are more underneath the parentheses umbrella. Multiplying or dividing things away. I could divide everything by 2 or by negative 5, but those wouldn't be nice whole numbers. So what I'm going to do instead is use the distributive property to simplify one side of my equation first, and then I can start to do my inverse operations. So I'm going to distribute that 2, and I'm going to distribute that negative 5. Negative 2 times x is just 2x, and I think I said negative 2. Positive 2 times x is 2x. Positive 2 times positive 3 is a positive or plus 6. I want to make sure I'm including this sign here of negative. So negative 5 times x is negative 5x. Negative 5 times negative 1 is a positive 5. So after this distributive property, now I can combine my x terms and my integer terms. So 2x minus 5x is a negative 3x. And 6 and 5 makes 11. And I'm going to change the color of those because I'm not really combining 2x and 6, so I'll change the color. So 2x and negative 5x is negative 3x, and positive 6 and positive 5 is a positive 11. Now I can actually start to move things over to the other side of the equation to start to isolate x to get x by itself. If I subtract 11, because I want to look for adding or subtracting things away first, I have a positive 11, so to undo that, or the inverse, the opposite of that, is minusing 11 to both sides of my equal sign. I'm left with negative 3x equals 8 minus 11 is negative 3. Divide by negative 3 on both sides. X is equal to positive 1. For the next one, I want to look to add or subtract something away first. I can't because the minus 12 is inside parentheses. What I can do is divide. I can multiply or divide something out. I can divide by negative 3 on the left and on the right. Because it's negative 3 times x minus 12. So the x minus 12 is in parentheses. The negative 3 next to it means it's multiplying. I can divide that to get rid of it or to manipulate the equation to look different. Negative 3 divided by negative 3 is just x minus 12, or because it's 1, so I'm left with 1 times x minus 12. Now that I'm just left essentially with x minus 12, I'm gonna get rid of those parenthesis marks. 15 divided by negative 3 is negative 5. Now I want to add 12. X, don't want to add 12 to x because those are not like terms. I'm left with just x because negative 12 and positive 12 cancel or zero out. Negative 5 plus 12 is 7. Number 4, negative 3x minus 15 plus 8x is equal to 10. Before I move things across the equal sign, I want to combine like terms on either side. I want to simplify the expression first. So I have negative 3x and I have a positive 8x. Those are like terms, so I want to put them together first. Negative 3x plus 8x is positive 5x. Negative 15 does not have a like term on the left side. And 10 is just already by itself on the right, so there's nothing to combine on that side yet. Now that I have 5x minus 15 is equal to 10, I want to look to add or subtract something away first, or I guess next, to start to get x by itself, to isolate x. Well, right now I have a minus 15. I'm going to add 15 to get rid of it, or change the look of my equation rather. 5x is equal to 10 plus 15 is 25. Now I can divide by 5 to have 1x is equal to 5. For number 5, I want to combine like terms on either side of my equal sign first. So 21 and minus or negative 6x, those are not like terms. I can't combine them. I'm going to leave the left side alone. The right side of my equal sign, I have negative 3 times 4x plus 1. Negative 3 could be distributed to 4x into 1, but it doesn't have to be, because what I could do if I look to yeah, I want to show you this. So if I look to add or subtract something away, I can't really because of those parentheses there, so that's like a package deal. But if I divide everything here by negative 3, if I look at multiplying or dividing away next, on the right-hand side I have 4x plus 1, because negative 3 divided by negative 3 is a positive 1. So I'm just left with 4x plus 1. On the left side, if I divide 21 by negative 3, I get negative 7. And if I divide negative 6x divided by negative 3, I'm left with a positive 2x. And as a reminder, you can multiply or divide an x term by an integer. You just can't add or subtract them. So negative 7 plus 2x is what I'm left with on the left. Now the left and the right do not have any more like terms. Now I can start to move things across the equal sign. So if I add or subtract away something first, I'm kind of starting over that inverse order of operations sequence. If I add 7, I want to add 7 over here to the 1, not the 4x. Those are not like terms. Negative 7 plus 7 is 0. 2x is equal to 4x plus 8. I'm going to subtract away a 4x from both sides of my equal sign to get the x terms on the same side. I'm going to run out of room. I need to move this up a little bit. (2x minus 4x is negative 2x. 4x minus 4x is 0. We're left with 8. Okay, Now if I divide everything by -2, both sides of my equation by -2, -2 divided by -2 is a positive 1x, 8 divided by -2 is a -4. And the last one here, 6 minus 3/4 x is equal to -4. There's no like terms on either side to combine. So what I'm going to do first is add or subtract away. So to get x by itself, right now I have that 6 minus, and I have 3/4 times x. So I want to add or subtract away the 6 first. And since it's a positive 6, I'm going to subtract it away. 6 minus 6 is 0. Negative 3/4 x. -4 minus 6 is -10. To rearrange this equation now, the -3/4 times x, whenever you're trying to get rid of a fraction to isolate a variable, I'm going to multiply by the reciprocal. So I'm going to multiply by 4/3. 4/3, whatever I do to one side, I have to do to the other of the equation to keep it balanced. 4 times -3 divided by 3 times 4 is essentially -12/12, or -x. -40/3. When you multiply fractions, multiply across. 4 times -3 is -12. 3 times 4 is 12. 12/12 is 1, but I've got that negative still there. -10 is the same as -10/1. -10 times 4, those are both the numerators, those multiply to -40, and the denominators 1 and 3 multiply to 3. So if -x is equal to -40/3, then x is equal to +40/3. And since 40 doesn't divide by 3 nicely, we can leave this as an improper fraction. Or if we really want to, x is equal to 40 divided by 3. Well, 3 goes into 4 one time. 3 goes into 10 3 times, with 1 left over. So I have 13 1/3 as an improper fraction. Let me know if you want to see any other examples below.